Hello and welcome everybody. I know I haven't done a stream for a while, but this one is going to be a cool one. We are going to rip some terrible science apart. What are we doing? Well, The Core is a movie from 2003 and apparently has been voted by scientists as the worst science film ever. I've seen the movie. It's a good movie, but yes, the science is absolutely atrocious. And so I thought, what better to do than to get a bunch of scientists together and have a little watch of some of the scenes so that we can go through and provide some science education content through movie, commentary and analysis. Who have I got with me? Well, I've got two amazing guests. I've got my usual, I'm normally their co-host, but we've got Jen from over on Polymathic. So welcome, Jen.
Hi.
How are you going today?
Yeah, not too bad. Pretty good for this early in the morning.
Yeah, I know, because
On
the
a Sunday.
time zone's always... Yeah,
Yep.
it's always a problem to balance time zones, but...
It's fine.
Oh, well. You ready for taking on The Core
I'm ready
today?
for this. This will be fun.
As I said, it's a good movie. I do recommend everyone go and watch it, but also... I found that for me, I had to watch it ironically. You can't watch it expecting anything serious. However, that's not all, because I'm getting even more help today from extra, science power. So I've been on their channel before. So I've got Mero from over on Nevardia. So welcome.
Hello.
How are you going?
Good.
G'day, mate.
G'day. What's going on?
Yes, we've got an all Aussie science panel here, which is going to be cool. So
unusual.
Yes.
I'm guessing both of you have watched The Core before.
Yeah. Oh,
Years
a bit
ago.
a while ago, to be honest. Yeah. I remember sitting there going, huh?
Yeah, it was it's an interesting film. Actually, I quite enjoyed it.
Yeah, I enjoyed the film itself. I mean, there are
Hmm.
movies that have been out that came out post that are every bit as bad in the science, but are worse films.
Yeah.
Yes,
Yeah,
we
I
may
really
have
enjoyed it.
We may be doing a
Yeah,
stream on one of those other movies later on.
What's
depending on how this one goes, I do have some ideas for different movies. Some have been suggestions, and others I have kind of floating in my head. And we'll see, because there's a lot of bad science out there.
There is.
What's the name of the chick again? Like the actress
In The Core.
in The Core. Yeah.
Oh, I am terrible with names. Oh, I'll have to either look this one up while we're playing one of the clips, or maybe someone in the chat will know. I'll have to have a look. Though first, just because I'm waiting, so make sure everybody who wants to come and watch the stream has a chance to join before we start going through the science. So I'm just going to welcome everyone who is here. So as you can see in the chat, we've got Icarus, Gary, we've got Vanta, Brainbug, and we got Joe and Banana Brains. Oh, as well as Sam. There we go. So welcome to all of you. Thanks for joining. I hope you all enjoy this. I've been excited for this. And also everyone's going to get a bonus, because today I have two videos. We've got this one here, the live stream, and I have another video ready to release later on the Space Pen, but we can get to that later. So yeah, I think we probably need to go through a bit about the context for the movie and what it's generally about, because I'm trying not to do too many spoilers, but of course, spoiler alert, because yes, we have to.
Well, you got to admit that it's almost a 20-year-old film. If you haven't seen it by now, you don't really have much.
Yeah.
Yeah.
That's like saying, oh, spoilers, Darth Vader is Luke's dad. It's just, if you don't know that, even if you've never seen the film, if you don't know that, you've been living under a rock.
Yeah.
Yes, it's we got some rocks that we can all hide under, but this one here is literally hiding under a giant rock.
Segue.
So, just for anyone who hasn't seen the movie, here's the context. The Earth's core and its motion keeps our magnetic fields. That part is true. And in the movie, for some reason, it stops spinning.
Just the core, not the Earth.
Not the Earth. The Earth is still spinning, and somebody didn't understand gravity, and we can get to that bit in a moment. But the Earth's core stops spinning, and our magnetic field starts shutting down, and they absolutely go to town on all the things that will happen because of that.
The other side of that too, Matt, is that it's not just the spinning of the Earth that keeps our core molten. It's the fact that we have this relatively large moon orbiting our planet that also helps to stir up the inner core and keep it moving and molten.
Yeah,
because
so they don't do any of that in the moon. They don't have anything to do with the moon.
We'd actually have more problems if we lost the moon, to be honest.
Yeah.
Yes.
But it's a good thought experiment, though. It's like, what would happen to the Earth?
That's about it.
Yeah, that's basically it's like they put a thought experiment into a film and then tried to make it scientific.
Yeah.
So I think that was basically it.
Yeah.
Let's face it, lots of movies do that. I Day After Tomorrow.
2012, I think, was suggested
2012,
earlier.
That's why we've already
actually, most disaster movies, I'm yet to see a proper disaster movie where the disaster is realistic.
Don't look up. That's a disaster movie.
Have not watched it yet.
I haven't, but I've had people recommend to me not to watch it.
I enjoyed it. It's more the commentary. The disaster movie is not like the actual disaster that happens. That happens right at the end, but it's the lead up and how people behave. I really enjoyed it. There's a lot of good social commentary. It's one of those things that the more you think about it, the more layered it gets, and you're like, by the end of it, you're like, yeah, that's actually literally happening. That actually happens right now. It's happening now.
When you talk about disaster movies like that, one thing we could look at doing at one point is comparing two movies that came out at the same time with the same theme of Deep Impact and Armageddon.
Yeah,
because
they are basically the same movie in many ways.
They were, but they also treated the science a little bit different between the two. One was more action, and one was the human component of it. So
although you got to admit, Deep Impact does sound a bit like a porno.
It really does, doesn't it? You change the soundtrack and it has an entirely different meaning. Wah, wah, wah. The 70s theme track. Sorry, Matt. This is your choice.
That's completely fine. Anyway, I think on that note, we should have a look at the first bit.
Mr. DPG?
You did invite both Mero and I for this. You should have expected.
Yes, don't worry. I was fully aware of what I was doing when I set up this. Though I think we've given everyone a few chances to join. So we'll go over the first scene. Just for people watching, what I've done is I've gone and grabbed a few clips from the movie, and we'll watch a clip. We'll talk over the top of it. Then we'll pause and we'll go back and tear the science to pieces. So I have, ready to go here, the first scene, which is the effect on pigeons, about what happens when the magnetic field starts to die or change. And yes, because apparently birds can't see without a magnetic field.
Yeah.
So it's just insanely over the top. I think they were just trying to be like, how far can we go to make this an action film?
Totally forgetting that the pigeons really only need their inbuilt guidance system when they're actually moving between large places. What the hell's a fish flying for?
I can explain this one. Yes, they used a fish because they didn't want to actually hurt any birds. So to make it look like, to make sure the glass actually broke, they got fish and threw it at the glass when the birds were flying around, so that the dead fish broke the window.
It's not a flying fish then.
So apparently the Earth's magnetic field dying means pigeons can't see where they're going because they'd be a bit disorientated, but
and they also transform into fish.
Yeah. Yes. And apparently fish apparently pigeons always use their innate guidance system when they're flying instead of just looking.
Yeah.
It's like, no, if you're only flying short distances, and it's not like they'd suddenly panic because there's no magnetic field, let's all panic. No, they'd be just going around the day doing their normal pigeon things, shitting on statues and eating seeds, and then this would only be an issue when they were trying to fly back to wherever they were roosting. Do pigeons roost? Wherever they were nesting, they don't roost.
Yeah, it's also migration. So when they want to move large distances that they'd need it, they're actually fairly smart. Pigeons can remember faces and sounds, so they'll remember people.
And they also navigate by landmarks as much as they do via magnetics, because we know the Earth's magnetic field flips, and birds don't get confused when that happens. There's no signs of that in the geology.
No.
Yeah. And also they do travel. They do, as you said. They use streets. They navigate by streets, not just landmarks. They actually follow streets, and they use a map.
They're better than some people I know.
Yeah, they're better than me.
They have inbuilt GPSs. When the GPS system goes down, the pigeons are screwed.
Apparently, but I think this is a really, really good start, because it kind of sets the tone of the science level of this movie, where someone has clearly heard something mildly scientific and just taken it to some extreme without having a clue of what they're doing. They've clearly heard that birds such as pigeons can navigate using a magnetic field, and then therefore thinking that if you mess with the Earth's magnetic field, they'll go crazy and start smacking into things, because apparently when the Earth's magnetic field was created, was kind of, the fact that it actually wobbles all the time, so it's not in the same place, but apparently putting a building somewhere in the middle of this magnetic field didn't make them crash into the building before.
Yeah.
Yeah. Also, this person heard of someone called Alfred Hitchcock.
Yeah.
So,
It's a remaking of a scene.
Yes, though I still can't get over the fish.
So does that make it a cinema cliche then, Mary?
Probably, yeah.
Yeah.
I'd say there's a fish.
It's a fish, yeah. We're never moving past this fish, are we?
No, but the thing is, it gets worse. This is one of the better scenes for the science. Because at least they've got a link between navigating with a magnetic field and then maybe they get a bit disorientated and fly into things when it starts to change. It gets worse.
Perhaps if they'd injected fish into the core, they could have solved it quicker.
Maybe.
Oh, has anyone seen the fish cannons or the salmon cannons? In terms of talking about launching fish.
Yes, they put the salmon to help them navigate up the river. They put the salmons in this thing, and they just basically look. Yeah,
there's a long tube.
Yeah, they yeet them into the lake.
I like that. It's basically Waterworld for for salmon. That they get a ride, and at the end of it they get a little photo to show that they went on the ride.
Oh damn it! I had my eyes closed.
Can I go again?
Hey guys, do I have to wait in line if I've already been?
I wonder if they enjoy it, or they're just like, what the fuck?
I mean, they look all right, but still, they're fish. We can't really go by facial expressions.
No,
They're not gonna turn
It's
around.
the
And
eyes.
tell us
It's the eyes.
Anyway, I think we got a few more people in the chat, so I can see Whisper of a Thought. Welcome as well. If I've missed anyone, please feel free to tag us in the chat. And if you want to ask us questions about the science going on, go for it. I'll do my best to monitor the chat, but I've also got to manage this. So, but yeah, I think we're ready for the next scenes, because starting to get a bit more into the science and also further into the ridiculousness of the movie. So who's ready?
Yeah, let's go.
Bring it.
So yeah, I had to.
Like,
Had to
fair
see
enough.
the fish.
I mean, they not only forget how to fly.
Somebody forgot how to edit film.
Yeah.
What's the timeline here? As the EM field becomes more and more unstable, we'll start
Sexy
seeing
man.
isolated incidents. One plane will fall from the sky.
Yeah, this is their explanation of what will
In a few
happen.
months, everything electronic will be fried.
Static discharges in the atmosphere will create superstorms with hundreds of lightning strikes per square mile.
Oh, he's
After that,
definitely
it gets
not
bad.
evil.
The Earth's EM field shields us from the
I know,
solar
it's like it's almost like he
which are
just needs a
lethal
cat.
blend of radioactive particles
Exactly. And that guy's chin is
When that
amazing.
shield collapses, microwave radiation.
I mean, they had a really, really good cast for the movie. Like, it was.
This is the sun.
I am terrible when it comes to
the Earth.
knowing, actors and pop culture, but I knew pretty much, like, I'd recognized pretty much all of the main characters. Okay, so this is where I want to pause
Is that
it.
an
'Cause this is,
example?
yeah, this is.
Sun,
Sorry,
this
let
is
me
the Earth.
pause this better. So, this is their explanation of what will happen to the Earth if our magnetic field dies. And this is the one scene where the science is mildly accurate.
Yeah, but it's not a good
So-
example.
That's really dangerous what he's doing right now. A lot of people don't realize that is incredibly dangerous.
Not as dangerous
putting
as
it
throwing
out
them
there.
on a campfire.
Yeah, don't do that.
Don't do that.
That
I
could
have
cause
seen
issues.
someone throw batteries onto a campfire. Well,
Yeah,
a
don't do
device
that
with
either.
batteries in it. Don't do that either.
No.
I was at
no.
I was at a beach party where somebody threw a can of deodorant on a fire
Yeah, don't do
and
that.
nearly took somebody's leg off. That
Shit.
they do. They blow off the end and it's just like a missile.
Little rocket.
Yeah, it's a little rocket.
Wow. Did they Did
That
they
doesn't
teach
mean
them it?
anyone should do that. It's dangerous.
Yeah. Yeah.
So what they say is that if our magnetic field dies, then the solar radiation, in particular, or the ionized, the charged particles or the ions coming from the sun, will start to basically smack into our atmosphere and cause electrical discharges and electrical storms, and just basically eventually blow our atmosphere away. And that's somewhat true, that you do need to have a magnetic field to kind of block out, or at least our magnetic field blocks out a lot of the solar radiation because it deflects it around. And where you kind of have the poles, that's why you need to go near the poles to see an aurora borealis, because that's actually the solar radiation kind of messing with our atmosphere. And if this started to die, you would start to see that everywhere. So there is actually a bit of truth to this. And eventually you just end up being like Mars. So I don't like this idea that the sun would just fry us to a crisp. We are not close
It'd
enough
take
for
a
that.
long time to burn down the atmosphere.
Yeah, it wouldn't be quick. We're not talking, I think they talk about within a couple of months we're gone. It's like, not really.
Yeah, well, I mean, if you the moon at one point had a atmosphere. Well, it still does, but it's very tenuous now. But it used to have
Very
a lot
thin.
thicker atmosphere, and it took about 1 million years for that to be eroded by the sun. So even if Earth lost its magnetic field, we'd probably still be looking at 1 million years for the planet to lose its atmosphere.
Yeah.
Yeah, it's very... And the thing
It's
is...
a long time. And that's assuming we as humans didn't do anything about it.
Yeah.
I have the feeling, compared to what this movie actually does, and we'll get to their solution a bit later, but I think actually building an artificial magnet and just like powering up a giant magnet would have been a better and easier solution than.
Aside from that, you only have to. You don't even need a magnet as big as the Earth. You can block the oncoming magnetic things from the sun at the Lagrange point between the Earth and the sun, and just stop it from getting here. Then all you have to worry about is cosmic rays.
Yeah.
But we actually already have problems with that. You can get solar storms and cosmic radiation that can actually damage satellites and electronics that we've already got. So even with our magnetic field, it's not as though this is a problem that's completely
and you
diverted.
have computers that burn out in aircraft that are flying high enough as well, because you still get some of it get through. The atmosphere itself is part of our protection, not just the magnetic layer. So
we had
higher up.
They actually have had. There've been planes that have basically dropped out of the sky because a bit of radiation tripped a 0 to a 1 or a 1 to a 0 on one of the circuits.
It's why they have backup units that compare each other.
They do now.
It can even happen on the surface. You can lose data in a data center just because data bits flip because a particular something got all the way through and hit that. It's really unlikely because the Earth's pretty big and cosmic rays are quite small, but it can happen.
Yeah, if we had another Carrington event, we'd be fucked. So if you don't know what a Carrington...
More fucked than they were then, definitely.
Yeah, so that was, I think it was in the late 1800s, where people in London were able to read their newspaper at night because of the the aurora borealis. Like it basically, the sun threw out this massive
mass ejection.
CRA. And he basically hit the Earth, and of course nobody had any electronics at the time, so everyone's like, oh, it's pretty, but if it happened nowadays, like half of the planet would be
and the Carrington event actually wasn't a full-on hit of the Earth. The Earth was hit by like a side swipe of it. It wasn't directly aimed at the Earth, but part of the spreading of it as it thing was what hit the Earth. So if you actually had a full-on CME the size of the Carrington event, it hit the Earth, we would probably lose 98% of all satellites. You wouldn't want to be in an airplane at the time this was happening unless it had complete manual override. And we'd blow out the electrical grid, and a lot of our data would be destroyed on the planet. You wouldn't destroy everything electronic, because things that aren't plugged in, depending on where they are, might not actually get enough of a boost through them to actually destroy them. So we're not going to destroy everything, but our grid systems, our electrical grid systems, are not designed for these events. Power repeating stations will get blown out because they don't have a big enough gap to survive a CME.
There's a lot of people, a lot of scientists are going, we really need to start thinking about burying our electrical grid and stuff like that, just in case this happens. But also,
not only that, we need to rebuild our transmission stations, because they're not designed to stop a surge like this at all. Not anywhere. And they blow out, and they take months and months and months to fix. And if the whole grid goes out, you don't have any power generation to create the new parts to fix all these things, and people die. Because you could only keep running hospitals and things like that on smaller generators, which a lot of them are going to get blown up as well because of the way the grid system works. So, people will die with a major coronal mass ejection. But you've also got the long-term effects afterwards, not just the 6 months to a year to get systems back up and running and stuff like that. A large CME like Carrington hitting Earth full on would strip our ozone layer. So we would end up not having an ozone layer for however long it takes to heal. And we know from when we fucked up the ozone layer, sorry, Matt, when we messed up the ozone layer, how long that took to heal.
It's still healing.
what would happen if it's all gone? Not just a hole in it; it's gone. You'd be wearing sunscreen in winter. You would have to be really careful when you went outside at all. In a time when we now don't have a proper electrical grid, proper support. You could see a dystopian future with an event like that.
Wars will happen. Wars will happen.
You could see Mad Max.
Yeah, wars will happen. Also, climate change will get better because we can't run anything. We can't use coal. So, that in a way, it might be a good thing. It might just kind of help stop climate change.
CME is a coronal mass ejection.
It's basically where the sun has a hissy fit and throws.
It just farts at us.
Excessive, and it just blows an excess of radiation in it.
The sun's magnetic field is excessively bigger than ours, and
it's also way more complicated. There's a lot of work that physicists are doing to try and model it and predict what's going to happen. And this is why we need to keep that sort of funding going, because it's the astronomers that are actually going to give us warning when one of these is going to occur. And at the moment, I don't think we get a lot of warning. But if we can have better models and we have more resources put towards actually keeping an eye on the solar system, not just the sun, but for other things that could do us damage as well, we'll be safe. Because it's one of those things where the chance of this occurring is quite low. But after enough time, it will occur.
Right?
Also,
magnetic lines in the sun short circuiting and going poof. Pretty much.
And also, just to be aware, we almost went into nuclear war because the sun farted at us. During the Cold War, there was a person refused to press the button for nuclear war because they were like, I think this is not like there was a signal that came and the Russians
the magnetic burst picked up on radar like a nuclear missile.
It also fried the circuit and tripped and showed about 7 incoming warheads, something like that. It was, and the guy on the monitoring station,
fried, they couldn't confirm it.
Because you don't generally have time, and his orders were, if you ever see this, to fire back. But his gut instinct was no, don't fire. And he refused to fire. And then after enough time, people started to realize if the US, because it was the Russians who thought the US had launched, they then came to realize all of the actual reasoning for why his gut was saying no. The US would never launch 7 missiles at once. If you're going to do a mass strike, you do a mass strike, not just 7 lone warheads. And they started to then realize that the other bits of the circuit weren't matching up. It didn't actually look properly like a launch, and they went through. So it was only because of his gut instinct that they didn't start nuclear war. Because if he'd hit the launch button, America would have seen the launch, and they would have fired anyway.
Yeah.
And there was But anyway, that's go. We could
are
do a
so
video
digressed
on all that.
with the movie now.
Yeah, we really have. Thank God that guy listened to his gut. Hey.
Yes, not the only time. There was another Russian one. If we have time, I might come back to at the end where we nearly ended up in a war, and it was one Russian officer that stopped it, and one Soviet officer, just to be specific about what time we're talking about. But yeah, in this movie, there are better ways you could have done this. But I think they just wanted this visual. I think this whole scene was just to get this little torch bit.
By the way, I just have to say, at least the movie is visually attractive because they've got some damn fine-looking young people on this movie. In my opinion, that guy,
quite a bit older now.
I know, but look at that chin. Look at that chin. It's gorgeous. It is, Adonis right there. Yeah,
Michelangelo would be happy of that chin.
Yeah. So we got to admit that and accept that.
All right.
Also, one of the lead female lead scientists is a female, so that's also yay quality.
One there.
Well, hey, it was 2003.
Have you noticed that it's in this scene? It's all men.
Yeah,
It's
I
meant to be the
noticed that one
military,
too.
so yeah, it does not surprise me at all.
Yeah,
But
that's true.
particularly for early 2000s and before, you weren't going to see much more than that. At
Well,
least
so
now
I've got a
there's
question to ask about that. Why are they presenting to the military and not
Because-
Congress or something like that? I mean, come on.
Because
I can't, because it looks
Yeah.
cooler when it's the military, because it's meant to be secret and behind the scenes. They basically just march, like the soldiers just walk into their offices and take them. They're basically, you're coming with us. This is
Hi,
the,
Claire.
it's like, which is also quite common in those movies. Oh yeah, hey Claire. And but anyway, as I said, we are moving more into the consequences and the actual disasters. I did kind of allude to some of them, and that's what I've got next. So this is what they say will happen. Let's have a look. I think next at what they visually think their representation of what this will look like when they actually turn the CGI budget on.
Are we going to do the ozone hole now?
Nothing happens. They had $45 for it.
The sun is a Death Star, yeah.
You'll see what I mean by that. I have sped this one up a bit because you don't need it, just be slow, but apparently, because of course the Golden Gate Bridge has to be involved. And any movie that shows the Golden Gate Bridge, we all know what happens to the bridge.
It goes melty.
And our atmosphere doesn't block that much heat.
Yeah.
This is the other destruction scene that you can see that they show. This is meant to be Rome, obviously, and I think this was just, hey, we've got leftover money in the CGI budget. How many monuments can we destroy? Apparently, the Colosseum is made out of dynamite.
Well, now we know what caused the fall of Rome.
Yeah.
So that's their idea of what happens when you shut our magnetic field off. So they gave us the explanation, which was at least half correct. And then they showed that.
I really do love that whole sun as a Death Star. Like it reminds me of how flat earthers draw rays of light from the sun. You know, it's all just straight. Yeah. The rays themselves are actually straight, but there's so many of them spread out that the sun's not just focusing all its power in one little point. So
but that's what they seem to be showing.
Even if you lose the Earth's magnetic field, it doesn't make suddenly more rays of sunlight get through.
My
to the
question
Earth.
is, why isn't the city behind it melting too?
It does eventually. In the movie, that's the next bit.
Yeah,
It goes
this
on.
is
They
a
cut to like a
moving
news story talking about the actual. But that's why I'm like, it looks like
the world should be melting.
Yeah,
Yeah,
but it's not. But this is their idea. Somehow somebody's put a giant lens magnifying glass in front of it, and some god is playing ants with humans and trying to burn us.
Their excuse was it's a tiny pocket hole within the ozone layer and within the magnetic field. So there's this little, but that's not how magnetic fields work. You don't have magnetic fields, tiny little hole.
And even if somehow you
They
could
don't
do
work
that, or
like
you
that.
turn the poles so you got like a gap like you do at our poles, which you still wouldn't get this.
It's still not a gap like that though.
We haven't burnt a hole through the Antarctic or Arctic ice sheets like this, because that's where the magnetic field is kind of most prone to getting breached by the sun. But I just didn't get this. I had no idea what they were going for. There is nothing accurate about this scene whatsoever.
There was actually one accurate part. You kind of like skip past it, but there was this woman going, and yeah, that's pretty accurate.
Yeah, that's fairly accurate. Let's talk about the lightning storm.
Yes. Sorry, I just want to last thing on this bit. The guy getting sunburnt is probably the only thing that's close to accurate. It wouldn't be that quick, but you would get sunburnt, as we've already mentioned. You would more harmful radiation would get through. But it wouldn't quite be like that because it's our atmosphere that does most of the blocking. So by the time our atmosphere starts to get thinned enough that the wavelengths that would do it that quickly, I mean, they wouldn't even do it that quickly. It wouldn't be in seconds. Get through in any noticeable level. Our atmosphere is starting to get way too thin for us to breathe anyway. We've got other problems.
I will object one thing though. With the sunburn, that does happen. I walk outside and instantaneously I burst into flames because I have
But you're a vampire.
Yeah, that's I get sunburned under a light bulb. So yeah.
Apparently
Also, sorry, you go. But I was just actually I'll go. The lightning strike is not hitting the top around the top of the Colosseum.
Oh,
it's in the middle.
Yeah,
that's wrong.
I've sped it up a bit so you don't see it, but when it hits, you actually see like this wave of electricity go over it. Like when movies show charged objects with like glowing with electricity, they do that here.
Not only that, the lightning goes in the wrong direction.
It looks like it's building up charge. I'm like, the thing is literally grounded.
Yeah. Oh, like I said, in the animations, they actually do the lightning in the wrong direction. It comes from the sky down instead of from the ground up.
But to be fair, we didn't know that until after the movie. It's a fairly recent.
We?
I don't. Wasn't it a fairly recent?
I'm
fairly sure that was a.
So.
That's what I was.
I mean, look.
Okay,
that's the least of their worries, though.
Yeah.
Oh yeah, it really is. Yeah.
But somehow electricity can blow up the Colosseum. I
directed energy weapon, plasma discharge.
Aren't you a laser scientist, Matt? You should.
I am, and I have repeatedly said lasers are a terrible weapon. They're so inefficient.
So if that building is such that it can transmit the electricity, it might get burned, charred. You might get small bits of it coming off it, but it's not going to explode because the electricity will just ground out.
Also, why are the buildings next to it not getting hit?
Yeah,
it's solid stone.
Why isn't it going to the power poles or the antennas on top of the buildings, which are actually way better conductors?
Yeah.
That's why they put large antennas on top of tall buildings as to conduct the lightning away from them.
Yeah, lightning rods. You ground them, and so you have a connection to ground. You literally just plug it into the ground, and then you put the wire up high so that any lightning will strike that before it goes through the building.
To be fair, the wire on large buildings is like thicker than most people's arms for doing this.
Yeah,
because you have to carry a lot of voltage.
But there will be buildings in Italy that have that, and a lot of the churches, steeples now have them as well. There are higher points in Rome than the Colosseum.
But they have lightning rods on the Colosseum as well.
But it doesn't have the social impact as the Colosseum. That's why.
To be fair, if they were going for social impact in Rome, why didn't they blow up the Vatican?
That's what they do in 2012.
That was a much better idea, in my opinion. But is it Zeus or Jupiter? Zeus probably was like.
They're the same. Zeus and Jupiter. Jupiter's the Roman name for
Jupiter's
Zeus.
Roman.
I like her answer. A magnetic stone used for the Colosseum.
Yeah, the Colosseum is built out of ferrite or something.
Yeah.
But if this is how electricity works, all of our high voltage grids would explode.
Yeah.
Electrons don't just stay in one spot and build up and then eventually blow up whatever they're in. The only way a spark will blow something up like this is if that thing is made of explosives and the spark sets off the combustion reaction.
Yeah, it could eventually, if you had the storm happen for hundreds of years, it would eventually erode that building because you'd have bits come off it slowly over time and everything. But that doesn't look as good in a movie.
No.
But they just show like the whole.
I've seen movies where they have lightning strike people and people explode.
I just noticed something.
That does not happen.
Sorry, I'm trying to get the right freeze frame here. There. It's not even hitting the highest point either. Yeah. And there's a metal statue next to it.
There's a metal statue next to it.
And the thing is,
this is painful.
The thing is, the Colosseum is built right next to the Imperial Palace, which is on a hill. The Imperial Palace is higher up. And it's just like a stone hill. You're just like... This is not how reality works.
I suggested this to you, Matt, because I can see the pain in your face. like
what? What?
The pain in your face right now, Matt. This is my fault, everyone. I apologize. I suggested this film.
I mean, yeah, blame Marrow.
It's me. It's me.
Yes. This stream is all your fault. So everyone, when you want to, you can all go blame Marrow for this. You leave all your comments. I mean, you can hit the dislike button, but nobody can see it now. I don't even understand why they kept it. I guess I could probably review the ratios afterwards, but yeah, no one else can see it. But well, we've got a few likes, but if anyone hasn't, feel free to do it if you're enjoying this.
Oh yeah, actually do that.
Oh, Mary's video's gone. Oh well. I think if there isn't any, I don't know what more to say on this. I think we should just try moving on because
lightning does not go down; it goes up. And I'm pretty sure
but also, it's not a weapon.
When this film was made, they knew that.
Even, I mean, look, I'll still forgive them for that, but still,
I won't.
Look, we can all blame them for different things. Yeah. I'm still, I just don't know what they were going for. As I said, it's clearly someone who hasn't even got past high school science. They've heard something and been like, "Ooh, electricity is dangerous. Lightning is dangerous."
Anywhere, it doesn't go for metal first, and it doesn't go for the highest points first because reasons.
Also, how come we don't blow up buildings when we have a storm here? Because that's all it is.
The other side of this, technically, if you wanted to destroy something, you could build a really big Van de Graaff generator, and that'd be freaking awesome.
I mean,
I'm working on getting my camera back. I don't know what's going on.
Okay,
that's all right. At least we can still hear you. Anyway, we'll give everyone a distraction. Well, more of a distraction. I think we'll keep me. Where's the?
I like Gary's comment. In the theater, no Hollywood movie writer can hear a scientist scream.
I'm keeping that. If I'm allowed to steal it, Gary, I'm going to steal it.
Actually, that should be a tagline for any of these that we do going on.
Because, yes, this has made a lot of scientists scream. As I said, it somehow got voted the worst science movie. I'm not sure how. Oh, welcome back, Mary's face.
Hello.
But I think the next bit, because they actually get into some chemistry, and there are two chemists here.
Yeah, I'm excited about this one.
I'm going to go back and listen to this one.
This is my time to shine.
So, yes. This is where okay. Oh, actually, sorry. Tiny bit of context. This is how they're exposed. So what they have to do to solve this problem is drill down into the core and set off nuclear bombs. We'll get to exactly how that works later, but they have to invent something to survive the heat, and this is the material that is going to survive that. Sorry, I need to give that context for people, but this is their explanation of how they're going to do that. And oh, by the way, this is meant to be a laser. That's why I had it. Also, that's not how you pick a mouse up by the tail. You do it by the base of the tail.
Combine the crystals in a tungsten titanium matrix at supercool temperatures. That's what did the trick.
The applications for this are...
What do you call this material?
It gets worse.
Well, its real name has 37 syllables. I call it unobtainium.
Oh
The
god.
unobtainium will take the heat and the pressure and transform it to energy, which in turn will reinforce the shell of the ship, you see. So the hotter and the deeper she gets, the stronger she gets, theoretically. Theoretically, yes.
It's not attacking him.
It's
I'm
not.
going to give them one thing over a lot of movies. They didn't come up with a brand new element to do
That's
this.
true.
It was
No.
actually a compound.
They
Yeah.
put something in a tungsten titanium matrix, and that apparently means, because this is the explanation they're giving, that it converts the heat energy into electricity. And that's what they run their little drilling machine off.
That's not how it works.
No, they basically no. In the movie, the way they kind of allude to the fact that they have basically taken whatever leads that their thing is running on, just plugged it into the shell made out of this stuff, and somehow that gets them power, because that's not how this works. Yes, you can use heat to generate electricity, but you can't do it this way.
They're not like
You
that.
could,
Yeah. Yeah. Okay.
and the
so a
other
little
thing
bit-
too is somehow it converts pressure into energy without collapsing. You're
pressure.
like,
No, it becomes stronger under more pressure.
yeah.
Yeah, because apparently as it gets hotter and the pressures increase, because it's building up that electrical charge in it, that strengthens the bonds of the element. Yeah, that was how they tried to explain it. Really and truly tried to explain it. It's like, you that's not how electrical flow works.
No.
And it's and it's certainly not how covalent bonds work either. Because if you put more electrons into there, like a higher thing, you're actually going to have a more negative
gonna
charge on the atoms, and you're going to destabilize the molecule.
Yeah, it'll literally start ripping itself to pieces.
Yeah.
Okay. See,
I have two
Sorry, I'll
things to
shut up
say.
because you guys are the chemists, not me.
So I've got two things to say. First of all, unobtainium is a actual thing in science, in the sense of it's like a bit of a joke, where they where scientists, when they're like, especially material scientists, they're trying to find something that they just can't figure it out, so they just jokingly nickname it unobtainium because they can't obtain it. So that's whenever you hear references to unobtainium in movies, there's that's where it comes from. And can I get you to go right basically like 2 or 3 seconds into that clip, like the beginning of the clip?
Oh,
because
the...
after go forward a little bit, just keep playing it, keep playing.
That laser is
playing.
insane.
Stop. That's a wine bottle.
Why didn't the wine bottle explode?
Like, why is there a, like, I don't know where that's coming from. You need a second source of light, but that's a wine bottle. They're drunk.
That would explain a lot.
Explain a lot.
I kind of noticed it without paying much attention to it. Now that I actually think about it, I'm like, yeah, that there should only be one spot from this, because the light can only go through one way.
Yeah.
They've switched, unless that's meant to be the light coming from outside back in, because they're in a warehouse in the desert. But if it's that, then they've somehow burnt 2 holes through it. But lasers don't go in 2 directions without a splitter.
Also, that laser beam is round. And
don't worry, we will get to that laser beam.
But it didn't out of the wood, out of the bloody.
No, don't worry. We will get to the laser beam. I will show you what this movie thinks a laser looks like. It's worse than you think.
But yeah, just pointing it out. That extra light source, don't know where it comes from, but it's a wine bottle. Just thought you'd like to know.
Look, at least someone gave them a Molly mod kit. If anyone is wondering what Molly mod is, it's a molecular model kit. It's where you get all the little things that you can join together and make models of what molecules look like. Very
Generally
creatively named.
alcohol. Yeah.
Yeah, the little dog molecule.
Yeah.
I have done that with students. I had to do that for a chirality prac I taught a few years ago. I don't do it anymore, but it was kind of cool to get those kits out and let them have a look at what molecules they're actually dealing with. But they've basically just made a buckyball out of I think they mentioned titanium and tungsten, although the shell, he says in a matrix, and I'm guessing that is not a matrix. A matrix has to be a repeating unit. That's a single molecule. So that's wrong for a start. And they seem to have made a buckyball out of two different elements. They've represented them with one color and then put a bunch of other chemicals inside it.
3, 4, 5.
For a start, that's not a metal, like a metallic substance.
1,
it's
2, 3,
not
4,
ceramic.
I'm just I'm just going. So that the ring facing us is 6-sided. 1, 2, 3, 4, 5. So it's a 6 and 5-sided ball. Like, I don't know how to explain it without actually showing it to you, but you see how there's a ring that's facing directly at us. That's
There's a better
6
version of it if you go forward a little bit.
Yeah, and then coming off it is 5-sided.
That's what did the trick.
The applications for this.
Is it?
Oh, he does show it at some point. Yeah, he holds it up.
I did have to clip this I did clip this a bit so it doesn't have all of it in there.
Yeah, we're not going to see it.
Because I didn't. I'm avoiding showing the actual all of the movie.
Yeah,
I just wanted to get the worst bits of the science, but which I think we're doing. But whatever this is
the entire movie.
This is not how chemistry works. So you can't. The problem is it's not where the energy goes. It's the fact that after a while, that heat will make those molecules vibrate more and more. Those bonds will break down.
Yeah,
we do not have a material that will do that.
And here's the other side of that. Sorry, go on, Matt.
I was also going to say the amount of heat too. You cannot convert heat directly into electricity through a material. Otherwise, we would be trying to do that. You could argue solar panels, but they don't. They use actual photons to do that. The photoelectric effect to some extent. And you can do it with different types, but that's not how this seems to work.
Yeah, we turn heat into mechanical energy and then turn that mechanical energy to electricity.
Yes.
And Matt, before you keep talking. I'm just going to say before you move on, I've got something else to say, but continue what going on, and then before you move this frame.
Now they kind of in the movie they do allude to the fact that the deepest humans have gone beforehand is only 7 miles, and for those who work in proper units, that's 12 kilometers deep. It was tiny little drill shaft. They thought they could get further. They wanted to see if they could reach, I think, the mantle or get most of the way through to the mantle, but it got way too hot way too quickly. And they had a ceramic drill head that just melted. They could only get 12 Ks.
Yeah.
It was a tiny shaft. They do kind of allude to that in the movie, and they need this weird contraption to get through. But somehow it's built out of this material that physically and chemically cannot exist. Then they decide to power it with a laser, which I said we will get, or at least do the drilling with a laser.
Stuff is weird. The other side of that is though, this material is heat resistant at the same time as conducting electricity. That's an oxymoron.
Oh yeah, I didn't think about that. You cannot be electrically conductive, and you can, but you can't be brilliantly conductive. Graphite's a good example.
You could be a
but
semiconductor.
graphite does not survive heat very well.
No, exactly.
Not
That's the
these
thing.
levels
So
of heat anyway.
You can't be both an insulator and a conductor.
Yes,
And
you
this
can't
thing
perfectly
is
be
both.
one.
It insulates the people inside the capsule while at the same time conducting electricity.
Or producing
No.
electricity because they don't seem to know the
Producing
difference.
Well, it has to conduct it if it's going to produce it.
Or they're talking about this nebulous energy thing about you can convert it to energy, then do whatever you want with energy. I'm like, no, it's not how it works. It's not how it works.
This is the most magical compound. This is more magical than the compound in what was the movie with the giant blue people?
Avatar.
Avatar. This is more magical than their element in Avatar.
They've got unobtainium in Avatar.
Unobtainium as well, yeah.
Unobtainium, yeah. That's why, yeah. So before you move on, I'd like you to have a look at the equations on the blackboard behind. And Matt, I'll let you have a dig at them, because I'm seeing sum of is sum of is approximately equal to the sum of times the sum of. I can't quite see it because it's kind of blurry.
It is. So in the background, I'll see if I can get a better, clearer still, although it's not likely to be. But yeah, I am looking at those equations, and somehow he's got time as a variable in one of them. And if I think they have literally done a Google search for scientific equations and written a couple of random things down.
Yeah, that's what I was thinking.
It certainly doesn't look like anyone's solving an equation. It just looks like shit written on a board. So
yeah.
Yes.
It may as well be chicken scratchings at that point, because
yeah.
Oh yeah, I see your time. Yeah.
Yeah.
I'm just trying to see if I can get a better view in the clip that I like.
It's only part of the equation, so I'm wondering what it is.
Yeah,
I'd almost guarantee it's a physics thing and not a chemistry
thing.
It's not much better from what I can see in other views. It's too blurry because the camera doesn't focus on.
Especially when you've got time in it. If as soon as you shove time in an equation, you're more likely dealing with physics than chemistry.
Yeah.
They've got omega in some of them, which is often angular momentum.
Yeah. And there's a pi there, and there's a
and I'm talking about the lowercase omega. The capital omega is resistance, which potentially is there, although I can't read it well enough to be sure. And it looks like they're doing some weird maths. But yeah, they've got M. Somehow you can see there they've got two lots of M subscript 3 squared and then M subs. So they're different M's. Normally that's reserved for mass, but in this case I don't think it is, because you don't tend to have, because that indicates that it's M as a function of time. But that's not where you would put the squared.
Of time.
Unless, because you don't write that. That's not even how you.
It looks like they've grabbed an equation which normally would have an X in it, put an M in it to make it look like it's got a mass in it, and because I honestly don't get why you'd have 3 different types of masses squared for a start over time. Anyway, when you're writing out chemical formulas, you don't write them as mathematical equations.
Actually, it could be some kind of flow diagram, like flow equation, looking at the bottom picture for some reason. But
but why? What?
Because they don't know how it works.
Unless he was trying to do a calculation. Because even if he was trying to do a calculation about how much energy he got out of it, I don't know why you'd need 3 lots of masses.
Yeah. Now, I also want to add this. I have walked into and spent a lot of time in research labs. I've spent most of my adult life in going in and out of research labs at some point. So I've probably been in and out of, if you include the same one, thousands of times now. Do you know how many times I have actually seen equations like this written up on a board in the lab?
Never?
Yeah. Nobody does their calculations in the lab. You might see mass, like, volume calculations. Someone's doing a quick check to make sure, okay, I need to weigh out
V1.
how much of this and I'll do. But normally you do that on paper. You don't do it on a board.
And who does it working out with chalk anyway? I mean, it takes you
don't,
longer to write
no.
than if you're writing with a pen and
Yeah.
paper or a pencil and paper.
Yeah, I was going to add, do you know the only place where I see equations in a lab on a board? Teaching labs.
Yep.
You have to be giving, it's only when you're actually giving lectures or showing demos for labs that you would ever do this. It's the only time I would ever do it. And he's meant to be alone. So I don't know who he's meant to be lecturing.
He'd have
before
stacks of
online
paper
lectures.
everywhere with his stuff written on. Stacks of paper.
You
do
Or a
this on
computer.
paper.
Or a computer.
You might. They should have just drawn chemical structures. That would have been better, because that you might work
that
off
would have been
if you're
better.
trying to build. You might have worked it out, and then you'll have the structure on the board, and then you mimic it. But even then, it's not how it works. You can't be like, oh, this is what my molecule looks like, and I'll build it.
It would be different if when they walked in, he walked up to the board and wrote a whole heap of stuff on it to describe what he was talking about to the people who'd come in.
Maybe that's what
But he
they're
wouldn't have
going
written
for.
that equation to do that, because he wouldn't have written that equation to do that, because you keep
He's
it
not
as simple as
talking
possible
maths.
for the least educated in the room, and that's going to be the soldiers who are in there.
Oh, also, sorry, I just going
Not
through
the
this.
soldiers
Gary
are
says
less educated. It's just they're less educated than university professors generally.
As a rule, yeah. Vantably,
Yeah.
you're right. The compound won't bind very well to itself.
Yeah, that's what I'm saying.
probably-
It's not a matrix. These are individual molecules. They're not going to be that tough. And also to Gary mentions it's a truncated icosahedron, which I believe that does ring a bell. So I think he's got it for us. So thanks for that one.
Hey, Vandalia, how you going, mate?
Oh, and so Joe also brings up saying that if it keeps building up an electrical charge, won't it do a coliseum?
Yeah.
Because we have to be consistent within the movie with it.
That's what I said. I think they literally just plug leads into this material. You don't quite see it, but that's what they imply. Because they run out of power.
Given the whole point that you have to have, given the whole point that you have to have a positive and a negative side of this. So you're plugging the lead in to just one molecule that's getting warmer or getting more current moving around isn't actually just going to give you power out the other end.
No. You actually can't.
Well, you have
from a single
cathodes and
material-
anodes on batteries.
Yeah, you can't generate a current from any single material. You actually need different materials because you need to separate positive and negative, and within the same material that won't happen. If you look at batteries, they're never one material. You actually have to separate parts of it, and it's the movement of chemicals and charges between them that gives you your current. You can't do it with a single material. But there we go. But I think we're hammering on this way too much because I've still got
let's move
a
on.
lot of
let's move.
few things to get through. And there is lasers because of
we
course
are getting so sidetracked.
Lasers.
Yeah, you're everyone's
let's do the lasers.
here. It's my channel. Of course there has to be lasers at some point. So I'll just go to the next
There we
bit
go.
is there we go, lasers. So this is the end drilling machine. And we will come back to specific shots, but this is apparently how they're going to drill down to the core of the Earth. With a laser and a ship converts heat to electricity. Because this is how lasers work, people. Of course they got the suspenseful music.
My God, that looks like a anus.
So that's where I got to pause, but I want to go back to, oh, went too far. Sorry, guys. I want to just, oh, sorry, this jumps around a lot.
There is one part about this movie that I really do like. It's where they have to dodge the big diamonds in the core.
Yeah, because that'll happen.
I like it though.
Yeah, although for some reason this laser can cut through rock in milliseconds, and
oh yeah,
but not diamond.
Yeah, but that's just ridiculous.
I mean, yeah, but this is their idea of a laser. It's basically a Gatling gun laser.
I mean, that sounds awesome. You got to admit that.
It does.
But it won't work. It's totally impractical.
It's also not out. Like there is no way you can generate enough enough power from a laser to cut through that much rock
that quickly.
Short of having their own nuclear power like their nuclear reactor on board, and
even then
directing most of that energy, you still won't get that through. It's not going to be that fast.
You're talking about vaporizing rock. The amount of energy you have to put into that rock to vaporize it.
Also, as a drilling thing, that head is problematic because that is just going to scoop up a lot of rock and then cover the laser.
Yeah.
Why does that need a laser drill? The whole thing's built out of a machine that's the more pressure it has, the stronger it gets. Why don't you just build a conventional drill out of the material that
lasers are cool?
Because that would make sense, Jen. You're asking a bit too much for this movie.
Also,
I do have a question though.
Go for it.
If you've got a machine that gets harder and more stronger the more you work it, how the hell do you make it into anything in the first place?
Exactly.
Yes, it's a good point.
Hey, apparently it gets soft, and you hit it and it gets stronger. Oh, and can we drill it? No. Can we bend it? No.
No.
Can we melt it? No. What the fuck can we do with it? You can look at it.
It just gets worse the more you think of it.
Also, can I just point out that laser, while it has a blue tinge, they're meant to be in water, and the way they depict it earlier, it's white. Lasers, by definition, are a single color. They're monochromatic. They cannot be white. By definition, that's not a laser. It is just fundamentally cannot be a laser. They call it a laser. So that's why it's not just meant to be a beam of energy. It is, they specifically say that they're making some weird high power laser. I forget the exact terms they use, and I frankly don't care because they don't get any of them correct. And they basically burn a hole through a mountain without the mountain collapsing, because that's apparently how that works. But
Matt, are you okay? Are
no.
you okay? No, okay.
That's my laser heart. My heart runs on lasers, and now it's hurt. This movie has offended me in the worst way possible. It has not depicted a laser correctly.
We need to cancel the call.
No, I said it's a good movie. The science just hurts.
Yeah. You've got to take your science hat off, put it on the shelf in an entirely different room before you watch this movie.
No, you have to take your hat off, walk to a nuclear bunker, and seal it behind at least 10 meters of concrete, lead, and steel.
Yeah, just in case any of those particles of intelligence manage to get through to you whilst you're watching the movie.
Yes.
That's a good picture, though. Despite the fact
look, visually, it's quite impressive for the time. And now I do like the next bit because I think this is more chemistry. And I think this was actually the entire reason Nevardia wanted to do this.
Yeah,
was
pretty
for
much.
this one scene. So I
Yeah.
had to put it in there. So we have an impossible machine, which we could have told from the beginning, but of course, the more you think about it, the worse it gets. And now we're about to find impossible geology.
Yeah.
But it's
by
pretty.
the way,
Possible.
Vanta Blue says Jen broke Matt. No, I think the movie broke Matt.
Yeah,
Jen
the movie
was just
broke
the
Matt.
conduit for the
I just
breaking.
pointed it out.
Though I will say this because, and if you're not already subbed, go over to Science Side Up and sub to them because I was on their channel and we went through a PragerU video on how global warming isn't real, and that broke all three of us.
Yeah.
That legitimately broke us. Anyway,
yeah, but it's
you'll see the
PragerU,
exact.
It just breaks everyone.
But there was
Anyone
one
that-
moment, there was one sentence they uttered that simultaneously broke two climate scientists and myself. Anyway, let's have a look at the pretty geode.
It's very pretty. It is pretty. Let's be honest.
It
It's
is pretty.
A lens cave.
Yeah, they somehow crash through this geode that looks like a. How? Like, this is at least several football stadiums. It's meant to be huge. And it's surviving in the liquid mantle.
How are they
This is what he said.
surviving in the liquid mantle?
This is the bit I want because this is where they actually explain.
But I don't understand how it could have survived down here. Cobalt shell, maybe? No, I mean in a magma environment of 5,000 degrees, something would have to protect it. Unbelievable. Let's go. We're inside a giant gem bubble, wrapped in a cobalt cocoon, 700 miles below the surface of the Earth. Oh, a day. Yes, it is.
So that's how they survive it. They have no idea.
Yeah.
Yeah.
Somehow cobalt is an insulator, or. But the thing is, here's what they don't understand about insulators. It doesn't keep what's inside cold. It just slows down how the heat getting in. Entropy, which is what basically dictates the fact that temperatures, hot will move towards cold, things like heat will spread out, means that even with an insulator, eventually that heat gets in. This thing will not survive. It will not be cooler than the magma around it after enough time. And it's indicated to be
millions of years old if you go, because that's supposed to be amethyst. And and for amethyst to grow that big, I mean, look, it's the bits of amethyst is as tall as a human being, because that'll be millions of years old.
Yes, there is the only insulators we have that might slow heat down enough to keep this, because it's a pocket of air from melting, although the outside, are ones we've had to synthetically make. There is no geological material known that will insulate for millions of years. If you go by our synthetic ones we've made, maybe. But as clearly you can tell in the script, they have no idea, because there is no way you can do this. Granted, it's a pretty scene, and it does make, because I'm not going to get into the action bit that happens next, it does make for a fairly compelling scene. But that's it. There's no science to this.
I like the way they try to have it in. They basically did this to try and have an in-space scene while they're in the core of the Earth, because they do the twinkling stars, which are the geodes.
Yeah, that was my first thought.
Space suits, and the okay, but why?
This is basically a
There's
space
plenty of
movie
other
set in
dramas they could
lava.
have had.
Yeah,
Yeah,
pretty much.
space movie
And
in lava.
another question that I have is, why didn't they take a fucking sample?
They do. They do try.
Okay.
But they get
They try.
interrupted, and I won't ruin it. That's why I didn't want to spoil. That's why I'm trying to avoid spoilers.
I mean, I think we should
You do-
probably explain the interruption, because this is another thing that I was like, hang on. Because is it all right? I mean, it is spoilers, but I think we've spoiled. Basically, the interruption is that the lava falls through the hole that they make to get in. But why did the lava fall through immediately afterwards?
I did think about that.
Yeah.
Now, the way they depict it is that it slowly melts a bigger hole, but it starts as a drip.
So why
Like a
didn't it just
small
melt through in
drop
the first place?
about that big. Now, look at the size of that thing. Now, their laser is meant to be melting a hole, and then earlier up you see the stuff solidifying behind it as it cools. But it wouldn't here, because it's where they're too deep. So, yes, apparently it's cartoon physics with gravity. Gravity doesn't kick in until it looks down. So the lava was
Pretty
just
much.
Wile E. Coyote and just kept running in open air until it looked down and was like, uh-oh.
Yeah. That was my... Yeah. And also, like, because you said they tried to take a sample. Why didn't they just pick up a bit of the rock that would have inevitably been smashed by the machine?
I have no idea, because you do actually see it smashing rock when it comes in here. And if anyone's wondering, I think you can actually find some of the clip of it crashing on YouTube. I think one of the movie channels has a clip of that. And yeah, they didn't do that. They could have just picked that up and got back in. And then they show the whole thing smashing like glass a bit later. And I don't think it's amethyst is that delicate. Or yeah, I mean, look, it doesn't make any sense to start with, and it's not going to get better. So,
and also, why isn't the laser melting the geode in front of it?
Yeah.
That apparently they turned it off when they crashed, but I think that actually does give them troubles restarting it. I'm like, the laser can cut through everything basically. Except diamond, and this is not diamond.
And
because they break in.
Why can't it cut through diamond?
Because the script said it can't.
Also, why don't they just wait for the lava to melt in and fill up? Because they know it lasts. The lava lasts, like it can last through lava. So just hop in, wait for the lava to fill it up.
Yeah, lava to melt them out. Yeah. Yeah, because that's not a good plot.
That would be logical. Again, I think it was just an excuse to have a spacewalk scene inside the Earth.
And a pretty one at that.
Like, it just comes across as a bit shoehorned in there. This scene is completely unnecessary. Pretty, but it doesn't match.
Also,
it would
why
make
do they
more
have a
sense
fucking...
in a this scene would make more sense in a asteroid impact disaster film.
Yeah. But also, why do they even have EVA suits?
Because it's hot.
Okay.
And it wasn't
somehow
an oxygen-rich atmosphere either in there.
It wouldn't be, no. You wouldn't be able to breathe in those because it'd be volcanic gases.
So I don't begrudge them wearing EVA suits, but
why would they give them EVA suits? You're going to the center of the Earth. Oh yeah,
that would be my question. Yes. What chances are there of you actually having to go out physically from this pod in an EVA suit?
I mean, you can't go out to fix a problem.
Over 5,000 degrees Celsius down there. What material, aside from the same stuff you make the ship out of, are you going to make these EVA suits out of? Oh, and by the way, this material doesn't have a glass form, so how do they do visors? How does the laser even work? Because the laser needs a clear thing to point through. And
yeah, so the laser itself is not protected by the look of it.
No.
So somehow it can survive the temperature because they don't know how thermodynamics works. Temperature you can't hide heat around a corner.
Are you
No.
sure
which is
about
what it
that,
looks like
Matt?
they're doing.
Are you,
You
sure?
can hide around a corner from a flamethrower, though.
Fair
Oh, yeah.
enough. But Matt, the great scientific minds of this movie disagree with you, and I have to go with the movie, not a PhD. So I'm sorry, Matt. I'm sorry. I'm just
I'm
gonna
being
have to disagree
betrayed.
with you on that one.
Anyway,
The Bible's real. I saw Ronald Reagan in the movie. Sorry.
Such
let's.
a stupid scene.
There's one bit left, and I've
Let's
saved
go.
the best for last. This is the
They're
part
the
of the
worst.
movie, the crux of what they're trying to do, and I've done my best to clip it so it doesn't ruin the plot from the people's point of view. I just want to show what their proposed solution is. So, oh yeah, that's right. I froze the frame. There we go. They basically set off nukes in the core. And this is what that would look like when you're in liquid mantle.
Nope. Why is it?
Now, this is where I wanted to pause it, because this is the diagram they show. But their idea is that they're going to drill down and then set nukes in a ring and then detonate them one after another. And the energy of the nukes will get the core spinning again.
Yeah.
And
there's a small
this
problem
is
with
apparently
that.
what the core looks like. The outer core,
Yeah,
I think,
no.
and then the inner core is that next layer.
ocean.
So apparently the core is see-through.
Hmm.
Yeah.
Yeah,
it's
well,
not,
it wouldn't look
by the
really
way,
good on a movie if it wasn't.
just white.
I mean,
But,
I know why they
watching
did it
rocks
in the
fall
movie.
in lava.
And Vanta Blue says exactly what I was just thinking. And the nukes won't counteract each other either.
Oh, even better than that, the nukes are housed inside their indestructible material that gets more stronger the more pressure and heat you apply to it.
Yeah.
Are we saying that our nukes have more energy than the core?
Or the
Because
universe,
I
for
tend
that
to
matter.
disagree with that.
Oh, that is something I should have brought up earlier when you talking about where we get our energy to keep the core molten, because you mentioned that the rotation is also to do from tidal forces in the moon. A lot of the heat comes from the heat from radioactive decay.
Mm.
So
yeah, like this is
they,
not
somehow adding a
anything
couple of
different.
nukes to it is going to help.
Which we
Not to
actually
mention
took
at that
out of the
pressure,
Earth in the first place.
I mean, even if you set nukes off, the pressure's not going to give you a blast like this.
You imagine the pressure at that level? That tiny little explosion. Even if it wasn't contained inside this indestructible box, that tiny little explosion would hardly make ripples. Hardly at all. The nukes just aren't powerful enough.
Yeah, but the scientists said it would.
I just like the fact that you make this indestructible thing that so that you can get there and then you blow it up with a nuke. It's not indestructible, is it?
It is until it
not
don't.
going to survive
it
down there. Yeah, exactly.
It is indestructible unless we want it to not be indestructible. Then it is not.
It's only indestructible from the outside.
And somehow,
We
even
built
though they've
fail
connected
safe.
together like a train, they could walk between the compartments, so there's probably not a layer of it in between. And so the heat doesn't get in that way?
Well, yeah. As soon as you have a door, I don't care how you make that door, you've got a weak spot. And the heat will get in that way. Even them having a way to get into this vehicle in the first place has given you a way for the heat to get through, for the molten materials of the core to get through into the ship. As soon as you have a weakness, it'll be exploited.
Yeah, but Jen, you forget script writing.
And
The magic of script writing.
Like Star Trek's warp drive always moves at the speed of plot, not at the warp factor stated.
Yes, they're not very consistent with that one. But yeah, apparently this is what it looks like. And it looks like they're setting nukes off on the surface of the sun. Or if the sun was black somehow.
Which is something else that would be pointless.
Yes. The sun is doing more nuke than any of our nukes do.
This would be like trying to launch our entire nuclear arsenal. Yeah. At Jupiter to turn it into a star. That's not how this works. Although also, I don't object to launching all our entire nuclear arsenal into Jupiter. I think that would be awesome.
Yes, I think it would.
Except it'd never get there and it'd come back here because that's how orbits work.
Yeah, none of the missiles seem to have the capability to get there.
No, they'd end up falling back to Earth at some point.
But and I'm almost lost for where I was actually going to go. Oh yeah, that's right.
Sorry.
I was going to go towards why their explanation for why the core stopped spinning in the first place. The government did it. That's all they do. That's all they do. It's a government experiment gone wrong. That's all they seem to show. Somehow the government can stop the core spinning by these weird seismic tests. Because that's...
Yeah, but they
do
can't
they not understand how much energy it would take to stop it spinning? Like, you have to basically grab the planet.
Anyway, yeah, I mean, also, it wouldn't just stop. It would slow down over time.
I think they indicate that it's slowing down, but it's slowing down very, very quickly.
Very, very fast. That would cause major problems like tearing the planet apart.
And also, don't you think like other scientists would be like, hang on, what's going on? Let's blow the whistle. That's the other thing.
Apparently, the first indications that our magnetic field starts to fail are dramatic, rather than some scientist who needs to keep an eye on it for their research, who spends his life looking at these things, going, hey, the magnetic field's changed a bit more than it should.
Yeah.
Everyone thinks that in these disaster movies, the first people to notice it are going to notice some disaster coming when it's right in front of you. 2012.
Yeah, I mean, just look at climate change. We noticed the disaster years out from it being really bad when we could have actually done something. This would be more realistic if it was like scientists taking 20 or 30 years telling governments, this is a problem, we're going to have to do. Oh, it's in the future. Don't worry about it. That would be realistic.
Yes,
that's what Don't Look Up does. Scientists are like, hey, this incredibly dangerous thing is happening, and the government's like, yeah. That's literally what they're saying.
Oh, now it's too late. Let's not tell anyone.
Yeah, pretty much. It's like, again, like, it is. If you want to see a true disaster, like a realistic disaster movie, watch Don't Look Up, because, like, trust me, it's fucking ham-fisted. It's like really preachy. If you can look past the preachiness, and you actually look at some of the messages that they're putting through, it's like, it's really well written. It's really well written. I really like it. Just the people who
and I like
don't like
Blue's idea.
Yeah.
The sun is dying, so we'll make Jupiter into a new sun.
Vanta, in that case, go watch the movie. I think it's Sunshine. It's about the sun dying and they have to launch like a nuclear reactor or something. They don't really describe what it is into the sun.
Yeah, it's really stupid. It's another movie we could actually cover because it is really stupid.
Yeah, there's I haven't seen it in ages, but there's a lot of weird things in that movie. It's not a bad movie. It's a little creepy, but
yeah. Oh yeah.
Also forgetting that for some reason they think that the sun is dying because the nuclear energy seems to be running out or something. But I didn't quite catch the beginning of the movie when I saw it. But that's not how the sun works. It's actually going to get bigger and hotter before it dies.
Yeah, we're going to die.
The problem that we actually face, the problem we actually face is that the sun will just basically fry Earth to a crisp. But we've got about 1 billion years before,
or totally engulf it. But we're not sure.
It won't engulf us because it'll fry us to a crisp before it gets to that point. And they reckon now that
it will, but it may or may not engulf the Earth because
they actually reckon
that out to the diameter of Earth's.
It'll expand roughly out to the diameter of Mars, but the solar pressure from all the radiation it gives off will be enough that it will actually probably push Earth and Mars outside of that ring of orbit. So we have a lot of other things to worry about.
It'll even push Jupiter out a bit further, because that's how much pressure there'll be when it happens. So the outer planets will get pushed out slightly.
You will not survive in this solar system when because though they reckon we maybe have to survive on Titan because it'll get warm enough.
No, even then, because basically when the sun expands, it becomes an giant. I mean, if you look at something like Betelgeuse, the star is basically an enormous flare star at that point, and it's just pumping out solar flares all the time. So even if you're in the outer solar system, you're going to get hit by those flares. So I don't see anywhere once the sun starts expanding where you could survive on another planet in the solar system, not without major technology backing you up. Which, of course, if we're still around, we would have by then. We also won't be us because we're talking millions of years in the future. We'll have way evolved from what we are now. It won't be humans. It'll be whatever comes next. If there is still life
if we survive, or if some of our
it won't be us anyway.
Yeah, whatever lineage we have,
it'll be our descendants, but it won't be humanity.
It won't be us. It won't be us.
No.
No.
It won't be humanity. It'll be whatever comes after.
Technically, they'll still be humans
or a different
because you don't grow out of your ancestry.
Okay.
But they'll be a new species of
still be humans.
They'll still be hominins. But they'll be a new clade. So if we don't kill ourselves off before then, which is not that unlikely.
Hopefully with incredible psychic powers and
anyway, that was actually the end of where I got to for the scenes that I got for the core we can tear apart. So overall, what did you guys think?
Oh, it's a brilliant movie.
Atrocious. But it's a great movie. Yeah, it's an awesome movie.
If you want
to watch it, just take your brain out for a couple of hours and watch the movie.
and perv on the guy with the amazing chin. Like seriously, it's a gorgeous chin.
It's Harvey Two-Face.
It's a pretty attractive chin. Like it actually is, isn't it? He's the guy from fucking Batman. Yeah, it's beautiful. He is a good looking man. He's a good looking man.
Okay, so that's your takeaway, Mero.
Here's looking man. I'll agree with Mero. Good movie too.
The only good thing about that movie is that man's chin. Like, let's just be honest.
He could have started the core again with just his chin.
Yeah, pretty much.
They should have put him at the front and just used the chin as the plow, just to.
Chin is the drill, yeah.
It would have made just as much sense.
Although, I mean, if you're wanting a chin to drill through the center of the earth, Jay Leno would certainly be the the pick, wouldn't he?
There's also a good chin, yeah.
that chin could cut diamonds. Yeah.
It's beautiful.
I mean, there's also a lot of scenes that I could have picked that I didn't. I'm actually quite happy because we've gone for just over 90 minutes, which is about perfect. That's what I had in mind. So that went well. But there are so many other scenes that you can have a look at for this because that's my selection of the bad science ones, and there were more. I just didn't have the time to put them in, or couldn't quite find nice clips of what I wanted to show. But yeah, they do actually send astronauts in this thing to pilot it for some reason. So it is basically a space movie in lava. That's
also
they were totally missing the lightsaber scene though. That's what they needed.
Yeah.
They can have a fight with the geodes, just hold crystals and start whacking each other.
Like, what about the bends?
Oh yeah, they don't seem to take
into
pressure
higher
into
pressure.
account, do they?
No.
When they step out into the
apart
geode,
from when
it
it's
would
making
be
electricity for them. Having said
yeah,
that, there are compounds that you can squeeze to get electrical current out of, because it's the opposite thing for how a crystal oscillator works. So you can squeeze a crystal and you get electric.
Yeah, my PhD relies on the piezoelectric effect. So it's when you squeeze or when you push against quartz, you'll generate a tiny current. The problem is that
this is not quartz.
You can only no, this is not quartz, and the currents and voltages that you generate are not that big. You don't use them to generate power. You use them to generate a signal that you monitor.
Yeah,
and in fact,
and once you've squeezed them a certain amount, that's it. You don't get any more out of it by squeezing it more.
So the way my PhD relies on using quartz tuning forks, and you'll find them in a lot of electronics.
It was probably why he described it like a crystal, when the atom, the structure he was building was like a crystal, to try and bake off that idea of.
I'm not even sure they knew about that when they were writing it.
Okay, that's my ad hoc explanation for why they use that. It doesn't make any sense even.
Melt. They'll still melt. You're not gonna convert the heat into electricity. And yeah, it does.
So the big question is, if you had a big, let's ignore the power generation from the heat that's down there. Well, I suppose you could do that. You'd have to have.
We've ignored everything else.
But internally, you'd warm up the whole ship, because you need to do a siphon heat pump. You need a colder area to do it. Let's just assume that you could build a big enough nuclear power plant to power a ship. Could we scientifically build a ship that could travel in the molten core of the Earth? 5,000.
I don't think it's physically possible. The pressure and the temperature would
that's
destroy
Celsius
any
for the
equipment.
Americans.
The best.
Which is
we've sent probes to
Fahrenheit.
we've sent probes to Venus, and they've lasted a couple of hours at best.
Yeah, and that's 400 degrees Celsius.
I think the best you could do is if you had
50.
You'd have to have a really extensive cooling system and a lot of power. But cooling systems are heat pumps. They move heat from somewhere to somewhere else.
You would still have to,
which means ultimately
you're
going to warm up the core of the Unless, of course, you can create like a wormhole to another universe and pump the heat into there. Then you are going to heat up eventually. There's only so much you can keep that cool.
Yeah. Also, the other thing that somehow we completely forgot is that they seem to be able to track them.
Yeah.
For the whole thing.
Yeah. How does that work? We don't even have models. We don't even have proper imaging of what the center of the Earth looks like. We have a reasonable idea of how it works, but there's no way we can image anything down below about 15 kilometers.
Not to mention that radio waves don't really work in water.
I don't know if they don't
They
go.
certainly
They
don't
don't even go
work
through
in
water,
rock.
which is the other thing. Yeah, they're not going through the rock, but they won't go through.
I mean, it's
salt
not.
water.
It's not hot water, Barry. It's molten rock.
But I
They're
don't
not
think
going
I
through
don't think
that
they
at
communicate
all.
with each other. They don't talk back to headquarters, so they at least seal them off. But somehow they can track the movement of the core inside, from live from some command
And with this
bunker.
enormous with this enormous core that they're tracking the movements of, they can see this little tiny speck of a ship that's traveling and making waves in the core, so they know where they
And
are.
if they could, you got to admit that if they could track them, then they would have found the giant geode anyway, or at least one of them, because I'm assuming that
I'm
the
actually
other
thinking.
geodes...
I do think they lose them, because part of the end of the movie indicates that they don't actually know exactly where they are, but they can still track the flow, and they can tell early on when they get through the crust, which you wouldn't be able to do anyway. You can't see anything through salt water unless you're using sonar or seismic.
Yeah,
you can't. Yeah, radio doesn't go that way.
Don't they end up using the whales to say, "Hey, we're here, come rescue us"?
Oh yeah.
More spoilers, yeah. Because again, they
Yeah,
run out of power. They come back out, and I'm just here going, well, then how do they have enough power to start the thing?
But they're
When
under
they cabled
pressure,
to start
and
off
when
with
they
or
have,
something.
but they're under pressure, and isn't the whole idea with this Unobtainium bullshit is that when it's under pressure, you get energy? Like,
When you're under pressure, you get a brilliant scene combination between David Bowie and Queen.
Yeah, that's true. Under pressure. Boom, 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 boom.
I was just thinking, I like. There's a good meme out there. It's like an interview scene, and so like a job interview, and they're like, "Can you perform under pressure?" It's like, "No, but I can sing Bohemian Rhapsody." Anyway, we've got a little bit over the 90 minutes now. We're 1.25 hours.
Sorry,
1.75
that was
hours.
my fault.
No, that's fine. I mean,
it's fun.
Good fun. But I am going to wrap it up in a moment. So I'll obviously give you each a chance to shill up. But before we get to that, any final comments? I know we've kind of gone through most of it, but as a quick summary.
Yeah, I think we've done it.
No.
Yeah, I've got nothing either. So
go watch the movie. Just don't expect good science.
Yeah, just watch it for the chin.
Now,
it's gorgeous.
Marrow, have you got any
chin?
I am being lazy at the moment, and I've been doing much work. I'm about to throw in the towel and just my camera keeps overheating, and so I'm trying to film something, and then like halfway through it's like, yeah, fuck you, I'm not gonna, and I'm like, okay, so I'm just probably just going to where I filmed up to, just go basically, guys, the camera keeps overheating, and I'm just going to get you all to watch B footage of my snakes while I read my script to you, because it's getting to that point, because it takes about 45 minutes, an hour to start filming, and it's just too much a pain in the ass, really. So I'm going to do that for my next film. That's what I'm thinking of doing. Anyway, that's me.
Right.
Come find me.
And also, links to both Jen and Mary's channels are below. And Jen, you got anything coming up you want to shill?
I do. I was gonna put out 2 pre-recorded videos this week, but I'm actually not gonna have time now, because now I have to do 2 trips into Albany. Not 2, 3 this week, and so that's gonna slow down. And it generally wipes out most of my day when I do that, and I'm not getting enough time to do stuff then. So I'm gonna be releasing 1 video this week. I'm not sure which one it's gonna be yet, though, but it'll either be the introduction to what it means to I'm doing a series on what it means to be either a man or a woman, and what that means from both socially and scientifically and things. And I've got guests who are going to be on it, but I want to do an introduction video to that. And I've also I've got a video script that I've nearly finished writing, which I need to record, which is about the evolution of language. So,
Awesome.
So linguistics and stuff. So I'm thinking I might do the language one first because my concern with doing the intro to the series is that I'm not fully organized to get it up and running, to have it as a weekly or even a bi-weekly thing yet. So I may leave that one till next week until I've got more people organized and stuff. So and just release the other one. So that's probably it. And there'll be a stream at some point during this week because I want to do some sciencey talks, which are after my tweet the other day actually might be all the science and pseudoscience around trans women in sport, because I've never actually covered the topic and I'm just getting sick of people talking bullshit.
I definitely want to listen in on that one. That'll be quite cool. So yeah, as I said, for people, if you want to find Jen or Mero, links are down below. And if there's any links I've missed, I will add them in later. As for me, I did mention I have another video, which hopefully I'll actually put out this evening. If not, I'll upload it today and then it will come out tomorrow on the Fisher space pen and what actually happened behind that, because that's a myth I've seen, and I'll explain why they did what they did and why you actually can't just bring a pencil to space, because that's what a lot of people seem to think you can do. But apart from that, I have some longer term projects in the works, so I'm not going to shill them yet because I'll wait till they're actually nearly ready to go. I am under a pump at work a lot because I got teaching and now a lot for PhD, so won't be a lot, but I will be doing more live streams where we're definitely going to be tackling more movies. So until next time, people, I've almost a doctor. That's Jen, that's Mero, and remember, be like a proton, and wait, because I haven't got the video lined up because I'm an idiot. Till next time, people, stay positive.